So with all of that, here is our actual project that is posted on the Google Classroom today. By the way, I also wanted to show you this. Another way that you can demonstrate the center of the mass is by hanging it from a string. So this is actually my first draft of this one. It's a little bit smaller, but you can see that I can hang it from a string, and it is at the center point. It balances, right? So like it sort of wobbles a little and goes up and down, especially I guess there's like a breeze in here or something. But if I did not have the center of the mass, this thing would just drop like that. It would just drop on one side and it wouldn't balance at all. So only from the center of mass can I hang it, and it will actually balance from the string. So that's another way that you can demonstrate. Instead of balancing it on a point, you can put a string through it. Of course, it's a little tricky because you have to make a tiny little hole and get the string to go through it, which is tricky. And you can tie anything on the other end. I just tied that little washer there. You have to be careful because at first the washer was lying flat like that, and it was adding mass to one side. It wouldn't balance. So I had to make sure that I pulled that washer sort of tight. Oop, now I pulled the string out. Anyway, it was hard to get it in there, so I'm not going to try again. All right, that's another thing you can do. Now, so here's what we're doing. It's our project. It's going to count as a test grade. It's going to be due very soon. I'll figure that out in a minute. All right, so you're going to create a flat object. So this is the important thing. You can have no vertical or horizontal lines of symmetry in your graph. So my graph is not symmetrical with respect to any vertical axis or any horizontal axis. And I'll show you why that's important in a minute. And demonstrate the center of mass by balancing the shape on a string or pencil point. Okay, so you're going to choose two different equations. Just go with two equations. You could make a shape with three equations, but you would have to think pretty carefully about how that's going to work. So let's just go with two. It'll be easier. All right. The region must not have any vertical or horizontal lines of symmetry. The reason for this is that either line of symmetry will simply place the center of mass on the line, rendering the calculation trivial. So what does that mean? Let's look at some of the shapes, and all this is included in the paper that you should read carefully, the documentation for this. So an excluded line, excluded shapes. These are things you cannot do. So here's just two parabolas, right? So it makes this cool shape. It's a cool shape, but here's the thing. It has a perfect line of symmetry right through the middle, a vertical line of symmetry. So the result of that is that we know the center of mass has to lie in that line. So I might still have to compute the y-coordinate of the center of mass, because I don't know if that will be here or here. By the way, the center of mass does not have to be in the shape. So I could have a region that's like this, right? The center of the mass could end up being out here, which is sort of an interesting property. And if that does happen to your shape, you're not going to be able to balance it. You'd have to like basically put a wire across and balance it on that wire. But that's like certain kinds of boomerangs and things work like that. The center of mass is actually outside the shape. All right, so that can happen. I would try to avoid that. But the point with this is, we don't know where the y-coordinate of the center of mass is, but we know where the x-coordinate is. It's x equals 0 because the shape is symmetric. Same thing here. I don't know where the y-coordinate of the center of mass is, but I already know the x-coordinate of the center of mass is 2 without doing any work at all. And that's because there's a vertical line of symmetry. So that's what I mean by the problem becomes trivial. It means there's no real work to do. Here's another one. It has a vertical line of symmetry. I don't know where the y-coordinate of the center of mass is, but I don't have to calculate the x-coordinate. So you could also have horizontal lines of symmetry. Here's one that has only a horizontal line of symmetry. So it does not have a vertical line of symmetry, but it has a horizontal line of symmetry. So I don't know where, in this case, I don't know where the x-coordinate of the center of mass could be. You know, maybe it's over here, maybe it's over here, I don't know. But I do know that the y-coordinate is 2 because that's a line of symmetry. So that's a trivial problem. We want you to have to calculate both coordinates of the center of mass. So this one's out. This one has both horizontal and vertical symmetry, so I know the center is right there. I don't have to calculate anything. And of course, this one's just a circle, so that is straight out, right? Because the center of mass is the center of the circle. There would be zero calculation and hardly any thought to doing that. Okay, so watch out for that. You can't have any shapes that have any vertical or horizontal line of symmetry. All right, so here's some examples of permitted shapes. So this one's pretty similar to the one I just demonstrated. Here's kind of a cool one using a sine function. Here's one using inverse tangent. You can use that. One suggestion that I made, this is how I came up with my shape, is use one of your functions as transcendental. That means it's not a polynomial function. It's something that cannot be expressed by polynomials or roots. So exponential, log, or trig function. And then the other one's a polynomial. So in general, that's not going to necessarily have a line of symmetry. Although, of course, you could have a thing with sine and parabola where you end up having a line of symmetry that is vertical, and so you have to think about it. This is just an easy way to generate a permissible shape, but just make sure it doesn't have any vertical or horizontal line of symmetry. All right, you could also use like 1 over x, which is a rational function, or you could use a root function. Yeah, you could use 2 transcendental functions too. Like I thought it might be interesting to do like e to the x, and then you wouldn't be able to use sine of x unless you were like over here, because sine is always less than 1, right? E to the x goes through 1. But you could use like sine of 2x or sine of 3x or something like that, right? So you do like 2 sine of x and e to the x. Right? So you can get a cool shape that way. Anyway, there's lots of different things you could do. Just make sure that it's not a symmetrical shape. Okay? And then you're going to find the center of mass and calculate it, show the expressions. So here's what it says you have to show. Show the integral expressions using your limits and your functions and the final result. And that's really all you need to show. And I say, see the videos in Google Classroom, like the last video before this one. But this is basically what you need to show for calculations. So it's not heavy on calculations. This is what you need to show. So I've got my limits, I've got my functions, I've got the x where it goes, I've got the squares where they go. One difference, by the way, this says 1/2 here. In this way of writing it, I put a 2 in the denominator. It's easy to show that's algebraically the same thing. I just thought it was a little easier to write. You could write it either way. Okay, and then you're going to produce a digital graph. Your graph has to include the graphs that you're demonstrating, and also the x equals x bar and y equals y bar. That means this horizontal line and this vertical line that intersect where the center of mass is. I'm just saying again that the x and the y have to be square. Make sure your grids are square or it might not balance. I'm actually starting to suspect it would still balance if the grids aren't square, but I'm still not curious enough to try and find out. And then you're going to print the graph. If you don't have access to a printer for any reason, send me an email and we can work out some alternative ways to produce the graph. You can produce the graph without a printer. You can produce a good graph without the printer. I went through all of high school and college without owning a computer, because nobody had a computer in those days, let alone a printer. So we made all our graphs, by hand, carefully. Okay, so picture the shape, and then your last thing is to locate the center of the mass. You actually already have it on there, and just verify it by balancing it as I showed you. You can either do a video like I did, or you can just show a photo like these two. These might not be very clear on the video right now, but look at the documentation, it's all there. All of this that I'm showing you is in the paper that is posted in the classroom today. All right, and then here's the scoring in the rubric. Your functions are appropriate. If you do have a line of symmetry, the most you can get on it is 50. It says 50% of total project points will be lost for any vertical or horizontal line of symmetry. So it has both vertical and horizontal line of symmetry. You get 0, because basically that's saying I made a circle and I cut it out and it was the center, right? You get no points for that, sorry. Just make sure you don't have horizontal or vertical lines of symmetry. One thing that I did suggest is feel free to submit your equations to me in advance for approval or suggestion. So if you just want to make sure that your equations are okay to use, just shoot me an email. I don't think it's too complicated what I'm saying here, but if you're unsure, shoot me an email. All right, and then so that's 10 points for having good functions. Just picking good functions. And then 30 points for correctly calculating the center of mass. The graph is worth 20 points. The solid that you cut out has to be reasonably crafted. So not total garbage, but it doesn't have to be perfect. That's 20 points. And your demonstration means I did my photo or video. That's 20 points. 5-point bonus for being awesome. Total of 105. And that is the project, which counts as a test grade.